Geometry Standard 8, using properties of lines and exponents. Learning target 3, I can establish facts about angles created when parallel lines are cut by a transversal. So we're going to start with the two vocab words: parallel lines, which are two lines that are always the same distance apart and they never ever intersect. So I think of it like a 4-lane road. So you have 2 lanes going one direction, 2 lanes going the other directions, and most of the time, I know once in a while they'll split and become further apart, but they're parallel the whole time. So if you jog to the left, both roads jog to the left or to the right, and they are parallel lines. And those 2 lines, that would be a really bad accident if they would actually intercross. We would have cars hitting each other. A transversal will probably be a new word for you. A transversal is a line that intersects at least 2 other lines. And the 2 other lines that we're going to be talking about today are parallel lines. So I'm going to draw a parallel line. I'm going to draw a parallel line to my best abilities here to make them straight. Okay, and then the transversal is as simple as this: a line that intersects at least 2 other lines. Okay, so that would be an example of a transversal. We can do it again. We'll say our parallel lines are going vertically here instead of horizontally. And then we take this transversal and we just cut through the 2 parallel lines. We'll just draw one more so you can get a feel of it. We'll make them more diagonal, those parallel lines. And again, the transversal is a line that just intersects. Now, why the vocab? Because what we're going to look at are the angles that are made that when this transversal intersects with these 2 parallel lines, there are a bunch of angles that are being made right there. And so we're going to talk about, first of all, what they are, and second of all, how many degrees are they? Start with vertical angles, and vertical angles are angles that are diagonal from each other on the same intersection. So what that looks like, I'm going to use a highlighter here. So what that looks like is this angle 1 here is a vertical angle to angle 4. So if we look again at the definitions, angles that are diagonal, so notice they're diagonal from each other, and they're on the same intersection. So this is the intersection we're talking about. We have this parallel line going horizontally. We have this transversal that's coming in diagonally, and angle 1 and angle 4 are vertical. So are angle 3 and angle 2. Okay, so if we look at the other pair, angle 6 and angle 7 are vertical. And you're highlighting with me as I go. And then angle 5 and angle 8 are vertical. So I'm just going to write what we just talked about over here. So angle 1 and angle 4 are vertical. Angle 2 and angle 3 are vertical angles. Angle 5 and angle 8 are vertical angles. And angle 6 and angle 7 are vertical angles. Now, their measurements, and this is the most important part. So yes, we need to be able to name them. We need to be able to recognize them, but we also need to know what their measurements. So their measurements are congruent. Which means the same or equivalent or equal to, the same degrees. You can write that if it helps you remember what the word congruent means. So for example, if I told you angle 1, we'll say, is 150 degrees, then I can guarantee angle 4 is also 150 degrees. If I say angle 2 is 30 degrees, then angle 3 is 30 degrees. So the nice thing about knowing about vertical angles is that if you can recognize them and you know the degree of one of the angles, then you can guarantee you know the degree of the other vertical angle because they have congruent measures. Okay. Our next vocabulary word is corresponding angles. Now, what I need you to do, I highlighted them. In your book, you need to cross out the word transversal and you write parallel lines in there. So corresponding angles, if you were to cut your two parallel lines apart, these angles would, we'll put B on top of each other. So what that's meaning is if I would take this and cut these two apart, so this would be one section and this would be one section, and then I would take this middle and place it on top of this one, that means that they would have corresponding angles. So I want to visualize that for you. So we would cut them apart, the two parallel lines, and then we take the middle of this one and place it straight on top of this one. Okay, then we can look at our corresponding angles. So, for example, angle 1 here corresponds with angle 5. So go ahead and highlight those two. Again, you're highlighting with me. Angle 2 corresponds with angle 6. Corresponding angle 3 corresponds with 7. And 4 corresponds with 8. So those are corresponding angles. So again, if you would pick that up, cut them in half, the parallel lines into two parallel lines, and you put this corner on top of this right here, and you just can visualize that. You can see visually that angle 2 and angle 6 are the exact same angles. So we're going to write down our corresponding angles so we can recognize them. So angle 1 and angle 5 are corresponding. Angle 2 and angle 6 are corresponding. Angle 3 and angle 7 are corresponding, and then angle 4 and angle 8 are corresponding. And just like if you can visualize it, look at the measure of 2 here. That is the exact same size of measure 6. Or if you look at the measure of 4 here, which is an obtuse angle, that is the same measurement of 8. So we can say their measurements are congruent. Okay, next type. Alternate exterior. So just like it sounds, it's alternate, every other, and exterior means outside, just kind of like what we've done before. So alternate would be on the outside of our two parallel lines. So I need you to do me a favor. Will you cross out the word transversal and put in this highlighted parallel lines? And down here where it says one another on yours, cross that out and write the transversal. So alternate exterior lines are angles that are on the outside of the parallel line. So if this is a parallel line and this is your parallel line, of course the other lines are transversal, on the outside. This is on the inside, which we'll talk about in a second, but this is on the outside. So we're talking about the ones that are not in the middle of the two parallel lines. We're looking on the ones that are on the outside. So I'll just write that for you so you can visualize it. And so that's the word exterior. That totally makes sense. And now alternate means every other. So are on the opposite sides of the transversal. So let's look what that looks like. So we're on the outside. So I want you to totally ignore this middle part, like pretend they're squished together. Like if we just took those two parallel lines and put them right next to each other, you would notice that angle 1 is on the left side of the transversal, and then we're going to go to the opposite side, or the alternate angle, and you're going to notice that 8. So 1 and 8 are alternate exterior. And then also 2, because we're on the outside. Since 2 is on the right side of the transversal, we're going to look at the one on the left side of that transversal, which is 6. So we'll write down what we just recorded. So angle 1 and angle 8 are alternate exterior, and angle 2 and angle 7. And their measurements, if you kind of look at them, we have 2 is acute, so is 7. So they are actually congruent. So again, we love when they're congruent. That means once we know one angle, then we can quickly know the other angle because of some of these rules or these vocab words that we're learning. Okay, now we're going to do alternate interior. My apologies. Interior. So inside. So we just looked at that. So the inside of these. So then these we're going to ignore the outside ones. Okay, and I could go back really quick here. So when we were talking about exterior. I want you to ignore the interior ones. So we're going to look at just the interior ones. So it's pretty much the same definition here, but except for outside, it's inside. So these lines are on the inside of the, and you need to cross that out and make it parallel lines. So take transversal out, put parallel lines, and are on the opposite side of, and take the word one, another, and put in the transversal. So we're going to talk about 3 here. So if we're looking at angle 3, your alternate, so every other opposite sides. So we're going to skip 1 and do 6. That means alternate, if that helps you. Or by definition, if it's on the left side, we're looking for the angle on the right side, but not the one next to it. So you got to skip 1. You got to alternate 1. And then angle 4 and angle 5. So let's record that so you can remember what we're looking at. So angle 3 and angle 6 are alternate interior, and angle 4 and angle 5 are alternate interior. And the awesome part about this, again, is they're congruent. So you don't have to do a lot of math. If you know one of these angles, so let's say angle 4 is 160 degrees, well, quickly I know that angle 5 is also 160 degrees. If I know angle 3 is 20 degrees, or yes, angle 3 is 20 degrees, then I know that angle 6, because the awesome part are all of these are congruent in measure. So we've gone over 4. We've looked at vertical angles, corresponding angles, alternate exterior angles, alternate interior angles, and all of those have congruent measurements. Now, one of the things you're going to have to do is maybe study those words over and over and over until you get really good at, first of all, defining them and be able to recognize them on a two parallel lines with a transversal diagram. So our last one we're going to look at is supplementary angles. And we kind of looked at this in LT2. We looked at alternate or supplementary, which means to me there are 2 angles that equal 180, and I always think about a straight line. So we're looking for straight lines when we're talking about supplementary angles. So these are 2 angles that sit side by side, either horizontally or vertically. Okay, so I think on here I said yellow and orange, but my highlighter doesn't have yellow and orange. On my actual paper, when I did this, I have yellow and orange. So we'll make this yellow and pink. Okay, so I'm going to highlight all the angles that have the same degree. So 1 and 4, because we can say those are vertical, and then 4 is the same as 5. Can we say those are alternate interior? And then 5 and 8 are congruent because they're vertical. Or you can say 1 and 8 are alternate exterior. I know they say that really fast, but by the time you get done with this, you should quickly be able to determine that. And 2 is going to be congruent to 3 because they're vertical. 3 is going to be congruent, let's go to 7 because they're corresponding. And 7 is going to be congruent to 6 because they're vertical. So as I read this, change this to pink so it doesn't confuse you. Again, you can use any 2 colors. Any 2 colors that you want. They don't have to be the 2 colors I pick. So whatever colored pencils you have in front of you, use those 2. So note that any yellow and pink angles, 2 of them, would equal 180 degrees. So these angles are not congruent, they equal 100. So for example, we'll do the horizontal ones first. So my horizontal angles that are supplementary, which equal 180 degrees, and look at that straight line. Some of you, if you look at angle 1 and then you look at angle 2, they make that straight line, or they make a half of a circle. Okay, so we're going to do the horizontal ones, which will be the one I just looked at. So angle 1 and angle 2, supplementary angles. Angle 3 and angle 4, see how they're horizontal from each other. Angle 5 and angle 6 right here. and angle 7 and angle 8 right here. So notice I did the horizontal ones, and then we can do the vertical ones. I'll squeeze those down here because we're running out of room. Swiggle this way. So 1 and 2. And then we can go 2 and... Nope, I can't read my own writing. Let's erase that, see what I have. Oh. It would have been 1 and... We're going vertical. So this should be 3. And then 2 and 4. And then angle 5 and angle 7 and angle 6 and angle 8. So all of those, so again, let me kind of demonstrate this. We'll say that angle 6 is 40 degrees. Well, if angle 6 is 40 degrees down here, then if I take angle 8 and I add them together, put them as one because they're making the straight line right here, they have to equal 180. So that means that this angle is 140 degrees. Okay, so we've gone through all the vocab. I know it's a lot. Maybe make some flashcards or just truly study those words over and over until you just become very familiar with them. So we're going to practice looking at these. And part of your test is I'm going to give you a measurement, and then you have to be able to look at that and tell me how many degrees another angle is in relation to the angle given. So in this one, I give you that angle 3 is 80 degrees. So angle 3 is 80 degrees. Okay, so we're going to fill out this chart. So we're going to look at the identified angle that I'm looking at is angle 2. So this angle right here. Well, I know the measurement is 80 degrees because the two angles are vertical angles from each other. So remember, vertical angles are angles that are across from each other vertically. Okay, now we're going to look at a new angle. So I'll erase this so it doesn't get so complicated. So we're still at angle 3. So angle 3 again was 80 degrees. Now we're going to identify 6. So I look at 3 and I look at 6. So I go through my vocab ideas. They're not vertical. They're not corresponding, not the same angle on the same side of the transversal. So they're alternate interior. So angle 3 and angle 6 are alternate interior. Oops, I turned those around. And their degree would also be 80 because remember, alternate interiors would be 80. So when you draw yours, just flip these around. I apologize. Okay, going back to angle 3 again. This time we want to see 7. So we're looking at this one. Well, angle 3 and angle 7 are corresponding. So we'll write the word corresponding angles. The same angle. Remember, we cut that in half. We put 1, 2, 3, 4 on top of 5, 6, 7, 8. 3 and 7 would line up or lay on top of each other. So they are the same measurement. So since 3 is 80, so is 7. Okay, going back to only knowing 8. Notice I'm always going back to the given one. So this is in relation to the given one. So we have 3. Now I'm looking at 4. Well, angle 4 is right next to them. And I can kind of, one of the things that's going to be a big clue to you. If you look at 3, it's acute. You look at 4, that is an obtuse. Are those going to be the same measure? No. So you can cross out every vocab word that has measurements that are congruent. So no vertical angle, no corresponding angle, no alternate interior, no alternate exterior. Well, there's only one choice left. They have to be supplementary. Okay, and supplementary angles, we'll write what they are. Supplementary angles have to equal 180 degrees. So if I know that angle 3 here is 80 degrees, then I know that angle 4 here has to be 100 degrees. Because when you add those two up, they equal 180. And the last one, angle 3 and angle 1. So here's angle 3. We know that's 80 degrees because that's what was given. So angle 1, so again, acute, obtuse, they don't look like the same size. So the only choice is supplementary. And I can tell they're supplementary because these are vertical from each other. I mean, we just talked about that. So they're side by side and they're vertical. And so then they have to equal 180 plus, if I take that angle 3 and I take this angle 1 here, well, I can see that would be a half of a circle, or they form this straight line. So angle 1 also has to be 100 degrees. And one last is, let's try the algebra side of it. So working with algebra expressions. Now, once you get very good at recognizing your angles, knowing what kind they are, and if they're congruent, or they're equal in measure, or they're equal to 180, then we can start setting up equations to find unknown x's, and then we can solve. So we're going to look at our parallel lines. We've got two of them. One's named CF and the other one's named JK. We have this beautiful transversal going through it, and we see that, and this up here is just telling us that line CF is parallel. That's a parallel symbol if you've never seen that, of JK. So looking at this angle and looking at this angle, think to yourself, what kind of angles are these? And are they congruent, or do they equal 180 degrees? Well, I know from studying all the vocab I've already studied this year, I should say this lesson, that these are alternate exterior. So notice they're not the inside of the parallel lines, they're outside. So this one's on the left side of the transversal, this one's on the right side of the transversal. And if I go back into my notes, or I remember, they are the same degrees. They are congruent. So I can set up my equation as 2x plus 26 is equal to x plus 32 degrees. And we're just going to solve just like we solved in the last learning target. I'm going to get x alone. So I'm going to subtract an x from both sides. I get an x plus 26 equals 32. I'm going to subtract 26 from both sides, and I get x is equivalent to 6, because 32 minus 26 is 6. So the first question is, what is x? X has turned into 6. So now, just like in the last two learned targets, we want to know how many degrees are the two angles. So we're going to look at this first top angle, which was represented by 2x plus 26, so this degree right here. So since I know x, I'm just going to plug in 6 in for x. So 2 times 6 plus 26 degrees gives me a grand total of 38 degrees. So if I look back up here, just for common sense, this is an acute angle, 38 degrees. Sounds reasonable. If I would have got 110 degrees, I would have thought to myself, I'd done something mathematically wrong somewhere in that problem, because no way is that over 90 degrees. That is an acute angle. And then we're going to take the bottom one here. So it says x plus 38. So x we find out was 32. Add 32, and voila, the answer is 38, which is a good sign, because from the beginning, remember our equation that we started with, we said they are equal. The measure of this angle plus the measure of this angle, or I should say this angle and this angle, are congruent. So as we set up this equation, we put the congruent or the equal sign and then solve from there.